Okay, so the first thing we're gonna do when running the Haas is getting all of our tools set up. So we need to make sure they're tightened down correctly. Where we go to do that is back over here. I'll move this over. When you're cleaning out the Haas, use the right bins to dispose of your material. Typically we're using aluminum, that goes in blue. This is not in blue, but no one machines titanium, which is probably why they used it. Anyways, this holder allows you to set your set down your tool holder, and then you can use a wrench. One of these wrenches should work in order to loosen it. So these are fairly tight, and so when you're loosening it, you're going to want this bar to give you some more grab. Make sure you have the correct wrench for whatever nut you're using. What we have here is the tool itself that's doing the cutting, the collet for the tool, so that's what wraps around the tool and clamps onto it to hold it in place. And then we have the collet nut, which is this big nut that as you tighten it, it compresses the collet so that you can actually clamp onto the tool. And then finally you have the whole tool holder assembly, which goes into the machine, right? Okay, so we're gonna crack it loose. Well, probably this way. Okay. Jeez. There we go. And it'll come loose and then it'll tighten up again. And I believe it'll pop right around here just from all the pressure buildup. Well, this time it didn't. Sometimes it'll pop a little bit. It's pretty normal. So at this point, you can take it out. You can put another tool in. I'm gonna go ahead and take all of this apart to show you guys the internals. Go ahead and hold this. Okay. So you can loosen this all the way out, and here you have the inside. It can get a bit dirty, so sometimes nice to just give it a good wipe down. And then this is the collet itself. So if we set this aside for a second, you can pop the collet out just like that, and they'll be labeled with whatever you can use them for, right? So this is a 1/2 inch, so it's meant to use 1/2 inch shank diameters. Typically you can get a bit of play and a bit of variation. And then to seat this, the way it works, you can see this hole is kind of off-centered, so you just slide it into one side, and then if I can get this right, you should be able to just pop it in, and now you can see it's seated, right? And then you do the exact opposite to pop it out. So you pop it out, you push in on the side that's closest to the edge, and it should pop out just like that. Okay. What you have to do is put our tool in. So this tool we're using is the engraving tool. As you can see, it should slide in fairly nicely, and it should tighten up. Yeah, it'll tighten up, so I know that's good. So the first thing we'll do is just tighten it up by hand. I like to engage as much of the shank as possible. So I'll go right up to it. And this also depends on, you know, how much clearance you need for whatever it is you're doing, so always keep that in mind. We have enough clearance here, so I'm not worried about that. But you will need to be concerned about clearance for other operations and other parts. So even though it's not a big deal for what we're making today, always keep that in mind when figuring out, you know, how far to insert your tool. So once I have that pretty snug, I'm going to go ahead and take the torque wrench. We torque our tools down to 135 Newton meters. If you cannot use the torque wrench, which I recommend somebody design more torque wrench adapters for other standard collets. Right now we only have it for the ER32 collets, or the ER32 nuts. So other nuts, like in the other tool that I was tightening up, we just have to crank it hard and hope that it's good. But it's always good practice to have a standard operating procedure. So we should probably make some adapters for those. Anyways, I'm gonna go ahead and use the torque wrench for this. The torque wrench will click and you'll see this red button pop up once you've hit the specified torque value. To unlock the torque wrench, you just have it twisted to the right. To lock it, you twist it to the left. Always make sure that you reset the torque wrench down to its lowest setting after using it, so that you don't wear out the torsion spring. So I'm going to go ahead and crank this up to 135. Okay, and now I'll come over here and tighten it up until I hear that click. And I might have to do a couple passes. There we go. So that clicked in. I think we're at 135. And this was the last tool we had to do. So I'll go ahead and crank this back down, put the torque wrench away. And now all of our tools have been put into our tool holders. The next step is going to be to load up the tools and zero them. You can go ahead and stop it. So when you first start up the machine, you're going to see a lot of messages. My advice to anyone using the machine is when you're confused, read, and it'll usually explain to you what you need to do. If you're ever lost, pressing buttons and reading will typically get you to wherever it is you need to go. As long as the buttons you're pressing are not, cycle start. That's the one button that you should not press unless you're confident in what's going to happen afterwards. Okay. So, reading the screen, it's giving me some servo off error, and it's also telling me to cycle door. So, when you first start up, you want to open and close the door. This allows the machine to establish, it has a sensor that detects when the door's open and closed. That way, if the door gets open for whatever reason, everything will shut off. It's a safety feature. The machine has a lot of safety features to make sure that you don't get damaged and that it does not get damaged. That being said, this machine does cost hundreds of thousands of dollars, and it can still be broken. And if you break it, you will be putting the hard work of hundreds of people in jeopardy. So please do everything in your power to not break the machine. Okay? Very important. Do not break the machine. Alright. Next thing we're going to do, maybe we want to hand jog it, so let's go to hand jog. Well, actually, before we do that, let's go to MDI. So MDI stands for me do it. That's when you want to do something. Okay, so if you're going to put in some code that you want to run, you'll go to MDI. The first thing you'll see here, MDI is also where we will set up our stock and occasionally set up our tools. There are multiple ways to do this. I'm just going to teach you the way that makes the most sense to me than the way that I usually do it. So the first thing you'll see here is it says the mill has not been zeroed. Press the reset button until all alarms have been cleared, followed by pressing the power up / restart button to zero the machine. Okay, so that's what it's telling us to do. That's what we're going to do. We're going to press the reset button. All the alarms have now been cleared. Now we're going to press power up restart, and it's going to start doing stuff. What it's doing here is it's setting up a universal home position. So the way the machine works is it has different home positions that it references. Okay, these are known as like the different G positions. So you'll see like G54, G55, G53. These are all home positions which are based off the universal position that the machine has. Okay, and so what we're going to do to tell the machine where our stock is, we're going to reference the stock's home position in G54, right? And so the values in G54 are just positional references between where the stock is and where the universal home position of the machine is, right? And then our tool offsets are just the offsets between where the tool, diameter and like tool tip is relative to the universal home position of the machine. Does that make sense? Cool. Okay, so as you can see, it loaded up tool 1. This is the face mill. It's been quite beat up due to misuse. Please don't be the person to beat it up further. These parts are expensive. They can break them. This machine can do it a lot though, which is nice. So the first thing we need to do is load up our tools. A couple things to point out in the machine. This is the tool probe. It's used to probe all of your tools so that the machine knows where the tool tip is and where it is with reference to everything else that's going on. This machine's very accurate. It's accurate to 3/10,000ths of an inch. That's 0.0003 inches. That's about a third the width of a human hair. But it's only as accurate as we are in setting it up, and it's only as accurate as the tools that we have. So if you damage this, it makes it less accurate, your parts come out shit. You end up paying 5 to 10 grand to get it replaced. So don't break it. Okay, so to insert our tools, the first thing we're going to do is move the bed so that we're not right above the tool probe. Because we don't want to accidentally take this out, it hits that, it breaks it. Everybody's mad at you. You get kicked off the team. Take your money. So what I did here is I went to hand jog, and then I can use this to jog it around by hand. Basically, you set whatever axis you're trying to jog in. The machine follows the right-hand rule, so if you're ever confused about coordinate systems, say X, Y, Z, X, Y, Z. You can also set your fidelity or your resolution. So right now I want to move it pretty quickly. I'll set it to 41. And I'll just move it to about here. This is a pretty safe position. So now what we're going to do is we're going to set up all of our tools. Okay, we need to set up our tool offsets. So the button, or what button do you think we should press to get to the screen where we would set up our tool offsets? Just take a wild guess. What? Can't read the buttons. Get closer. Read the buttons. You guys need to be able to do this on your own. Oh? Yeah. Tool offset measure? It's an interesting one. It's not it. We will use that later. Oh, wait. Probably about what are we trying to do? We're trying to set our tool offsets. Okay, you want to press the offset button.
Oh, genius.
Anyways.
Don't record that.
We'll cut that out. Or not. Okay, so we go to the offset screen. You can see here it says tool offsets. This is where all of your tool offsets are set. Okay. I accidentally changed the tool offset for the base mill. That's my bad. I just accidentally pressed the button. Anyway, we're gonna reprobe it, so it's no big deal. So on this screen, you can set all of the tools that you would like to probe. The first thing that we'll do is load the tools up according to our can. So if I go to the tool library, so right now we have our tools set to tool 8 for the engrave, and we have it set to tool 5 for the pull nodes. So that's what we'll load up here. So we want to do a tool change, we'll go to MDI, we do it manual, the actual acronym is like manual data something, interface, I forgot what it is. But we'll go to our tool change, so we'll do C5, I said. C5, ATC forward. ATC stands for automatic tool change. So you can do an automatic tool change forward or reverse. If you just hit ATC forward, it will just tool change to the next tool. You can hold, I believe it's 21 tools in here. Forward or reverse will go forward or reverse one. If you put in the actual tool command, it doesn't matter whether you hit forward or reverse. It'll know which way to turn to get to your tool the fastest. Okay, so we'll T5, ATC forward. We'll now go to tool 5. We'll open this up, and we're gonna load in our tool. Okay, tool 5, our bull nose. The way you load this up, there are these two openings, right? That line up with the teeth in the tool holder, okay? And what you'll do is you'll come in here, you'll swipe it just to make sure there aren't any chips in the spindle. Okay, this is the spindle. You'll press and hold the tool release. So it uses pneumatic pressure to suck the tool in. So you'll press and hold the tool release. You'll line this up to the dog, and then you'll release. And you'll see it's seated about halfway in. Okay, that's how you know that it's properly seated. And at this point, you've loaded your tool. All right. And then to take it out, you'll grab it, hold the tool release, and then take it out. Okay. Make sure you don't drop it. Each of you are gonna put the tool in and take the tool out. So, the offsets tab, and then we're gonna want to put in approximate positions for each of the tools we have. So we can start with tool 8 since it's in the spindle. And what we'll do, this will tell you all the different settings. So first thing we'll do, we'll call this a center drill. This is an engraving tool. We'll just put in 5 and then enter it. Center drill or spot drill. Then we'll go to our approximate length. So you want to measure the length from this flat surface, okay, this flat bottom surface of the spindle to the tool tip, right? Not from the teeth to the tool tip, not from the nut to the tool tip, from the bottom of the spindle to the tool tip. This machine processes everything in imperial, so just make sure everything you're putting into it, everything you're measuring is imperial. This looks like it's about 4 inches. It's already set to 4, great. Approximate diameter. It was what, 0.375. Great. We'll keep going. The probe type, so we want to do length probing, rotating. We don't need to probe the diameter. For drills, you typically don't need to probe diameter. It's only important for end mills. So we'll select option 1, so we'll hit 1 and then enter. Length rotating. We'll go to the next tool that we're gonna probe. So I don't think we can try it from here. T1, ATC forward, yeah. Okay. We'll go ahead and measure this. And this is also 4. Approximate length for the approximates should actually be set up for this already. Yeah, 2.5. Okay, that'll be good. And then we're gonna probe length and diameter. This is fine. You can also set things like your coolant position. It's not super important. I like to change my coolant position on the fly, but if you wanted to preset it, you could. So the next tool we'll go to is 5. So we'll do T5, ATC forward. And then this is going to be about 6. Let me make sure. Yeah, about 6. So, approximate length, I'll set it to 6. It didn't change it to 6. Does anyone know why it didn't change it to 6?
For like 6000.
So 6.0, it changed it to 13 instead of 6. It's adding it, right? So if you just hit right, all it's going to do is add it. If you want to override this value, you'll hit F1. So we do 6.0, F1, changes it to 6, right? Next, we'll go to the approximate diameter. Diameter. Can somebody convert 10 millimeters to inches? Put that in. And then we'll go ahead and set the probing for this.
It's 0.39.
Okay. 0.39 F1. And we'll set the probing for this to length and diameter. So, because we want to check both of them. Enter. Edge measure height is the distance that it'll drop down to measure the diameter. This is fine. This is going to go down 1/4 of an inch and then check. You want to go past the limit, right? Okay. The next thing we need to do is for any tools that we're not going to measure, we got to change them to none. So tool 2, there's nothing there, so we're going to put 0, enter. Tool 3, there's nothing there. Tool 4, there's nothing there. So we're only doing 1, 5, and 8. Okay, we should be good now. The next thing we'll do, press the tool offset measure key to start the automatic probing options. Tool offset measure. Okay. Press cycle start to run the probe or blah blah blah, not important. We're going to choose an option here. You can probe the selected tool if you just want to probe that one. You can probe it manually, don't do that. Probe for breakage, wear, whatever, or probe all tools. We're going to probe all our tools. When you're doing this, you can adjust your rapids here. You know, your rapids, your feeds, and your spindle speeds. If you're uncomfortable with the machine, I recommend keeping them low, okay, because it can get scary. You can potentially break something. I'm going to go at full speed to show you what this machine can do. If I put something in wrong, something bad could happen at this point. So hopefully I didn't put anything in wrong. I don't think I did. I don't think we did. So probe all tools, cycle start. Warning, your machine is cold. Run a warm-up program. Press cancel to continue. Cancel. Tool offset measure. Probe all tools. Cycle start. It will now go and probe all the tools. So what it's going to do is come up to the tool probe. It's going to come down. It's going to spin. And it's just going to touch off to the probe itself, and that's how it's going to get all of the positions. And we can check what the actual measurements are and how they compare to our approximates. They should be pretty close, and that'll tell us that, like, it seems like we did something right. You can stop it. So we said 4, we got 4.007. Pretty damn close. For 5, we said 6. We got 6.04, and for diameter we said 0.39. We got 0.3946. And then for tool 1, we said 4 and 2.5. And we got 3.99 and 2.5082. Seems about right. So I trust that our tools have now been correctly set. The next thing we need to do, and I'm going to ATC forward to get rid of this tool, is set up our stock. Okay? To set up our stock, we're going to use parallels. We're going to use a couple things. So, one, we have round stock, which means we're going to use a V block to clamp it in place. That way we can maintain 3 points of contact. Two, in order to machine these features, it needs to be above the V block height. So we're going to use parallels. And parallels are components which are ground parallel to each other, and it allows us to stack, objects. It allows us to stack objects and ensure that they're being stacked in parallel, right? So if we have a flat surface, we can trust that it's going to be relatively flat, and we're going to get a good part at the end. Parallels are machined either two-sided ground or four-sided ground. So if it's a two-sided parallel, that means these two surfaces were ground parallel to each other. If it's a four-sided, that means all four sides were grounded parallel. I don't know which these are. I think they were two-sided, which means you can only really trust stacking on these surfaces. Okay, so we're going to set up our stock, and then we're going to begin probing our stock. You can stop together. Stack it a few times to make sure it's nice up against the parallels, actually parallel. And we'll tighten it up again. You want to make sure this is pretty tight. You do not want your part coming loose, flying off, shaking, vibrating. Having everything well pictured is very important. So, yeah, make this pretty thick. That feels pretty tight. Next thing we'll do is probe our stock. So, to probe our stock, we're going to go to program conversational. Or sorry, I take that back. We're going to MPI, and then we're going to press program conversational to activate the EQC IPS tab, which is this area, okay? So we'll hit program conversational, and then we're going to set up our stock. So first, let me go ahead and put the probe in. So I'll go to T20 forward. The probe is always kept in tool 20. Tool 1 and tool 20 are the first and last tools. They're the only ones that always stay in the machine. Okay. Now that we have that, we'll go program conversational manual mode. So we want to set up, so we're going to move over to setup, and we're going to hit enter. And then we want to set up our work, right? So we're going to hit enter again. And now we're in the work offset area. As you can see, we're working off G54. That's your work coordinate system. And these are the current offsets, which were set from whatever the previous operation was. So we're going to go ahead and reset the offsets using our current stock. So the first thing I'll do is jog it over. I'm just going to bring it fairly close so that we can do all of our probing. So you have to remember the machine is only as smart as you are when you set it up, right? The machine knows nothing besides what you tell it. And so we need to tell it, we've already told it what our tools look like. We now need to tell it what our stock looks like. Okay. So we need to tell it where the origin point is that we set up in our pan, which is the center at the top. So we're going to probe this surface, and we're going to probe this diameter, and that's going to tell us our position. Okay. So the first thing we'll do, you'll see it says press F2 to set offsets using the probe. So we'll press F2. In this menu, you can decide what kind of probing you're going to do. The first set we're going to do is single surface. It's the simplest one. Again, we're going to do a Z surface. So I'm going to drop this to get like pretty close, whatever the height is. Very important. This probe, just this tip right here, costs about $100. It will shatter at the smallest amount of compressive load. Okay, it is extremely rigid, which means as soon as you touch anything, it will shatter and you'll blow $100. This probe itself, this is just illustrated to the probe. The probe costs about $5,000. If you break it, it's $5,000. If you shatter this, it's very easy to do. It'll cost $100 again. So be very careful. So it's gonna ask us to set our distance, right? So we're probing in Z, so we want to set a Z distance. So we'll go down to Z, and we'll measure about how far the tip is from the surface that we're measuring. Okay. And what we're going to do is we're going to measure two ends, see how off they are. That'll tell us if our part is level or not. Or really, it'll tell us like how level the surface is, and we trust it to be fairly level. So it'll just be like a sanding. So I'm going to measure this. It's about 0.3. I'll just say, I'm going to say negative 0.3. Enter. You want negative because you're going down. I'm going to move this to the side just a bit. And we'll go ahead and check. So, press cycle start. Okay, Z offset 12.9283. Somebody remember that number. We're going to move over. We're going to jog it to the other side and do the exact same thing. 12.9283. 12.9281. Alright, so we are off by 2/10,000ths of an inch, which the machine is only accurate to 3/10,000ths. So it's safe to say it's pretty straight. It's pretty lined up, which is good. We want that, right? We don't want to be machining something that's inked, because then our part comes that way. The next thing we need to check is we need to probe for the center. Okay, so what we're gonna do is we're gonna bring, we're gonna press F2, like it says. We're gonna choose our probing option, which is a boss, right? We're probing a boss feature. And then we're gonna read what it says. Position probe near the approximate center and just above the Z-axis surface, okay? So, let's go to the approximate center. Approximate diameter, which is 2 inches. Incremental Z, incremental distance to move in the Z-axis from probe position point. So it's how far down I want it to move when it's going to probe. I'll just set that to 0.3 inches should be good. So 0.3. X adjust and Y adjust we don't need. At this point, we can go ahead and press cycle start.
Okay. Approximate diameter is 0.0002 inches.
Oh, thank you. Let me go back up. Thanks for catching that. So 2.0. There we go. All right. We can go ahead and press cycle start, and what it's going to do. It's going to move out, come down, probe, move out, come down, probe. And it's going to probe in the X and the Y and then use trigonometry to figure out where the exact center is. Cool. I don't want the probe in there. As a sanity check, something you can do is go to like, let's see. You can check to see if when it gets to 0, it looks like it's above the stock. You can also, when you're running your program, check to see if it's lining up correctly with whatever offsets you set. If you set like a feed height of like 10 millimeters, you know it's going to start feeding at 10, right? So if it drops down to that feed height or that clearance height, you can see if it looks approximately correct, and that'll tell you that your stock is lining. The next thing we need to do, now that we've zeroed our stock and zeroed our tools, is put in our program, and at that point we load our program and we should be ready to run. So you can stop recording the number. It can't use like letters in the name. You can throw like 111 or whatever. You want to make sure you change your units to inches, and that's pretty much it. There are a bunch of properties in here, which if you're interested in them, go ahead and take a look as to how it affects the program. But this is the base of what you need. And then you hit post, save it to a USB, and then to load up your program, you'll plug your USB in. You'll go to, let's see, where is it? Select program. You'll go to list program. Sorry, forgot for a second. And then here you'll be able to load certain programs up. So we'll go to USB device, press right enter to activate the device. And then here you can see all the files. We'll scroll down. Cam, enter, and then we'll scroll down to 691. And then press F2 to copy selected files. Did I select the program? Yeah. So I just selected the program, and it's now here in our memory. From this point, you can hit cycle start, and it'll begin looking at whatever you have on the machine, right? And it'll begin running. Something which I've heard is good to do is to copy the program over to memory so that it's not running off the USB. So we can go ahead and give that a shot. I personally haven't done that in the past, but I mean, we can try. Press F2 to copy selected files, F2 copy of memory. Right into memory. Now it should be writing into our memory, and then cool. And now we should be able to go into our memory here and select, what was it? It was like 691. Yeah, this one. And then from this point, we should be able to select the program. It says it's the active program, so if we go to our memory, it's the program that we have active. In here, we can check through all of our lines. The last thing is, when you're running, you want to select single block and option stop. So you want to select single block and option stop. Single block allows you to step through each block. Option stop will stop running in between different tool operations. At this point, you should lower your rapids, lower your feeds, and then if you hit cycle start, it should start going. Let's see if that's true. It'll ask me to go through each one. I'm going to take off single block for the moment, just to show you guys. So, what I would do here is just check to make sure that everything looks lined up and everything looks good. What this code is supposed to do is come down and shave off about 0.5 millimeter on the top, which we can do because, you know, nothing should crash and it'll be a good proof of concept. So I'll let it come down and I'll just stop it. And then I'll take a look at what it's going to have it do, right? So at this point, it's moving the Z very slowly, so it's feeding, and then it's going to go into a negative Z, and eventually start coming across in order to face, right? So let's go check. It says it's at a Z of 0.3937, which means it should be 0.4 inches. So like almost 1/2 inch from the top, which that seems about right. That tells me that my code looks good. I'll want to turn on my coolant using the coolant button. It should turn on once I start running the program. And then I can change my coolant to go up or down. So we'll cycle start. Oh, the machine might be low on coolant. But anyways, it's going to come across and it's going to face just the smallest bit off the top. Okay, so it just finished. I'll come and check it out. I'm honestly not sure why the cooler is turned on.
Check the valve.
Alright, so this valve is what keeps your coolant open and closed. You'll want to make sure that it's actually on. And it can be a bit messy. But you want to check that your coolant height looks about right. It looks good to me. You want your coolant to be engaging with the insert, right? You want it to be hitting the insert. And then we'll come and take a look at our finish. Our finish looks pretty decent. You guys can check it out. You can also use the air gun to go ahead and blow it. But it basically just did a 0.5 millimeter pass across the top. And yeah, from here, you know, it would go and do the other operations, which we're not going to do because we would crash it. But yeah, that's basically how you use this machine. A couple last things to keep in mind. Only do what you feel comfortable doing. When you're cleaning the machine, keep something in the spindle so that chips don't fly up into the spindle. Very important. Make sure your device is square at the end and square it up if it isn't. When you're done cleaning up the machine and you're packing things up, I typically keep the spindle unloaded just because there could be some like freak case where when you start up, you know, it releases pressure and drops whatever's in there. You don't want to run into that problem. So I'll typically empty it. And then you position the vise in the center and towards the back of the machine. But be careful not to crash it. You know, the machine is set so that the bed will not crash, but the vise dimensions expand past the bed, so you could, in theory, crash it into the back. And there are some dents for people who have had some accidents. So be careful with that. Also, be careful when you're machining really large stock that the stock itself isn't going to hit the tools that are being held in the tool holder. That has happened before, and it's led to some really expensive damage. Make sure that you're not going to crash with any of your fixtures, because those aren't modeled in your cam, right? And you know, those things have happened, and it leads to expensive repairs. I think that's all of the important stuff. Yeah, if I think of anything else, I'll go ahead and add it.